Hi everyone, welcome back to my channel, or welcome in if you're new. This is Channie, and today we're watching Ancient Life as Old as the Universe by Kurzgesagt in a nutshell, and I'm excited to see aliens. Ancient aliens, to be exact. I just recently finished playing Alien Isolation on my Twitch channel. If you would like to join us, feel free to. And yeah, super excited. I've also watched all the trailers for the Alien franchise. They might drop before this video or after it. I'm not sure of the order, but do expect me reacting to some movie trailers very soon. Or if you've already seen that one first, I hope you enjoyed it. But yeah, let's get to it.
Life has existed on one planet for about 4 billion years, as far as we know. But it might have started right after the Big Bang, when the universe was much stranger and more fantastic than today. A universe that might have allowed life to develop absolutely anywhere. The cosmos might be full of the seeds of life, sleeping in a dead desert, waiting for a few drops of rain to explosively bloom and grow. Tiny and not so tiny aliens might be everywhere. In this video, we're going to put together two highly speculative yet scientifically grounded possibilities. Check out the scientific papers in our sources. To properly explain it, let's first look at the paradox of life on Earth. The life paradox. For its first few 100 million years, Earth was a magma hell, constantly bombarded by asteroids. But basically, the second things calmed down and the first oceans formed, life just appeared, and zillions of microbes settled every nook and cranny they found. This is kind of strange. Life on Earth seems to be almost as old as the planet itself, as if it was waiting around for an opportunity. But life didn't only appear extremely quickly. In that tiny time window, it also crossed a huge gap.
To qualify
as living things, even microbes need to eat, poop, grow, and multiply. To do that, they need
Kurzgesagt.
Even microbes need to eat.
Double cheeked up on a Thursday afternoon. Hella ass, the sun is still up. Hello? What's going on?
Eat, poop, grow, and multiply. To do that, they need a genome, the biological instruction manual that sets the inner workings of an organism. How dead things with no genome become living things with genomes is one of the biggest riddles of science. Simplifying a lot, the problem is that to have a functioning genome, you need proteins, and to make those proteins, you need a functioning genome. Both proteins and genomes are super long molecules.
You need genome for protein and protein for genome, right? That's what they said.
The problem is that to have a functioning genome, you need proteins, and to make those proteins, you need a functioning genome. Both proteins and genomes are super long molecules made of pretty complex blocks that are extremely difficult to assemble by chance. It's a chicken-egg paradox with several chickens and eggs. Once you have a finished cell, the whole system works efficiently. But starting from simple dead stuff and reaching that level of sophistication by pure chance should require an amazing amount of time for trial and error. So how did the first living things manage to cross that gap in just a few 100 million years? Most theories about the origin of life try to explain that gap by theorizing how some primitive soup of prebiotic molecules could have efficiently produced the first self-replicating entities. But we still don't know how exactly this would have worked. Maybe we need to think backwards. The clock of evolution. Think of genomes as a book telling the history of life. As time passed and life evolved, more characters were introduced. Amoeba, fish, amphibians, dinosaurs, and mammals. Over billions of years, the story of life got more and more complex. A genome can be viewed as a long string of letters with biological instructions. And from microbes to us today, functional genomes seem to have been increasing in size at a fairly constant rate. The functional genome of fish is more than twice that of worms. Our functional genome is about twice bigger than that of fish, and so on. It is a bit more complicated, but for now, let's run with this. When we put all these clues together, it seems that genomes have been doubling in size on average every 350 million years or so, as if evolution had been following an exponential inner clock. But it gets even stranger. The very first microbes that emerged on Earth, even if they look simple, already seem to have had pretty long and complex genomes. But how could life have achieved that level of complexity in such a short time?
Yeah, like we went from dead matter to
There may be an interesting way to solve this
life,
riddle.
but
we just take
not
our
complex
exponential clock
immediately?
and extrapolate it back in time to the simplest conceivable life form. Something equivalent to a being with a genome containing just a few letters. But if we do that, we end up 10 billion years in the past, more than twice the age of Earth, which means if life actually evolved like this, it didn't start here, but somewhere out there, in space. This would explain why life started to thrive so quickly on our young planet. If it was already present in space like a seed, it just needed water and warm temperatures to wake up and go on evolving. And it would also explain the high degree of sophistication of the first life forms on Earth. They could have been complex already because they might have been evolving for billions of years
they've already
somewhere
been
else in the universe.
cooking
Could life really be
in the
that
universe.
old? Maybe, yes. Actually, life could have started shortly after the universe itself was born. A Goldilocks baby universe. At its most basic level, life needs two things: the right chemical elements to form complex molecules and a liquid medium, like water, in which those molecules can move and interact. The liquid medium needs to stay warm enough to remain, well, liquid. So when we search for life in space, we focus on Earth-like planets at just the right distance from their star, warm enough to sustain liquid water. But there was actually a time when almost all of the universe might have been habitable. Right after the Big Bang, the universe was extremely hot. But as the cosmos expanded, it cooled. And between about 10 and 17 million years after the Big Bang, when the universe was 1,000 times younger than today, it was between 100 degrees Celsius and 0 degrees Celsius,
It's
the
perfect temperature.
at which water is liquid. So for this window of time, more than 13.7 billion years ago, the whole universe, absolutely every inch of it, had the right temperature to support life. Of course, the right temperature alone is not enough for life. We also need chemical elements like carbon and oxygen, which are forged in the cores of stars. But were there stars in super early cosmic times? Maybe, yes. In
Perhaps.
regions of the universe where matter was especially dense. Such stars would have been very massive and gone supernova in just 3 million years, seeding the baby universe with the chemical elements needed to form dust, asteroids, planets, and the ingredients of life. Maybe the first...
I don't know why that part kind of reminded me of Powerpuff Girls when the professor was doing the ingredients and then Chemical X, you know? Yeah. I just got flashbacks from that scene when they were explaining this with that animation.
Ancestors of life were more exotic and didn't even need water, but thrived in substances like ammonia or ethane that can stay liquid at temperatures far below 0 degrees Celsius. They could have been sustained by the lingering warmth of the Big Bang for tens of millions of years longer, well into a time when we know for sure there were stars and all the chemical elements. The real magic of this idea is that while the universe today is extremely deadly and hostile, back then the conditions for life might have been basically everywhere. For a period that may have lasted several dozen million years, primordial life might have been able to emerge on any rock, even between the stars, sowing the universe with the seeds of what billions...
Slightly off topic, but kind of on topic. The music on this is really good. Like, I don't know, it's evoking like really... I don't know what to describe this emotion as, but like I really like the music attached to this. It's really good. It's really putting like the whole topic together and bringing in the emotions.
Of years later would become bacteria, trilobites, dinosaurs, and finally us. At some point, the universe cooled down below the right temperature for life to thrive, but some of those ancestral life forms may have continued to exist in the internal warmth of the first planets, frozen in asteroids or hibernating in cosmic dust. Tiny seeds roaming the cosmos, waiting for new hospitable places to continue evolving. If they did, life now might be everywhere in the universe. Will we ever know? All this makes for a nice story. And while both the habitability of the baby universe and our exponential clock of life are reasonable ideas, they're still speculative. One more possibility among many others, trying to explain our existence today. But if life came to Earth from outer space, then it should have seeded other places in the solar system too. Maybe there are fossils in dry riverbeds on Mars. Maybe we'll soon find life in the warm underground oceans of Enceladus or Europa.
Where are these two?
Soon find life in the warm underground oceans of Enceladus or Europa.
Where are they? How far away are they?
Titan has seas, rivers and lakes of ethane and methane as warm as the universe when it was 90 million years old. So finding exotic life on Titan would support the idea that life could have originated in the weird baby universe. So
is that a baby with a pacifier of the universe?
That life could have originated in the weird baby universe. So far, when we look out into the cosmos, we don't see anyone like us. But maybe that's because life needed 10 billion years or more to reach the level of complexity that allows for a technological species. Maybe there are millions of worlds filled with microbes, oceans full of exotic fish, and...
I mean, we do have that now. I mean, I believe that the aliens we're looking for are in our oceans. Deep sea is still unexplored. Like a really tiny percentage of it is explored. So alien life exists in the deep ocean.
And continents of bizarre animals. And maybe even others like us that just recently gained consciousness and are beginning to look at the sky, wondering if they're alone. Life could be flourishing right now in uncountable forms and in all kinds of cosmic environments. And if many of us share a common cosmic origin, we would all be part of a great cosmic family. The answer may lie in our cosmic backyard. Let's go and find out.
How about you do that? I'm gonna stay here. Thank you. Thank you for the knowledge, Sir Kurzgesagt. Very, very well made video, as always. The music was amazing. W choice really helped with the feeling and the vibes and atmosphere of this video. But yeah, a really interesting concept. I do believe for sure if what they're presenting here about, like, you know, the right temperature and conditions being met before the Big Bang, for sure there has been life before. For it to, like, our first organisms here to be that complex, for sure there has been stuff brewing before they landed on Earth. So yeah, I really enjoyed this. Very, very knowledgeable, very enjoyable. But what do you think? Do you think life existed before and then it developed further or better and faster when it landed on our planet? Or do you feel like it started with our planet? Do let me know in the comments. And if you have enjoyed this video so far, make sure you like, comment, and subscribe. And I'll see you on the next video. Bye!